Hello, hello, hello to everybody, and welcome to SciFest Africa's and SAAO's virtual festival. I'll be your host for this session. My name is Gobisa Senovuyo Dumego. The collaboration where SAAO reaches a milestone and celebrates 200 years in existence, and SciFest Africa's 24th edition, which will take place for 6 months between October 2020 and March 2021. Today, we will unlock your imagination and learn science in a very fun way. Who else but Split Second Science to amaze us with an interactive session? Meet Leandra Taylor, the managing creative scientist at Split Second Science. She will take us through demonstrations with her two lovely junior assistants. Leandra has a BSc degree in medical sciences, PGCE, and MSc degree in human nutrition and dietetics. She is a feature writer for a science magazine and has also been on the judging committee for the ESCOM Expo for Young Scientists in KwaZulu-Natal. Leandra has also served in the SANDF as a medic and nurse. Wow, Leandra, your bio is very impressive. Just a few house rules for the session. As we have viewers in Zoom and on our Facebook pages, you are encouraged to interact with Leandra should you have any comments or questions. For those of you who are viewing from Zoom, please make use of the Q&A box at the bottom of the screen. And if you are streaming live from Facebook, please be free to use the comment section. Over to you, Leandra.
Thank you very much, Tobisa. It is really an honor and a pleasure to be here with you this afternoon. Hi, Tobisa. Thank you very much for that lovely introduction. Sorry, my mute button gets stuck. So yeah, thank you very much for the opportunity to be here, and I really hope that everyone that's watching will really enjoy it and have a lot of fun. Yes, I'm the creative scientist at Split Second Science, and what we do is we like to make science fun for all ages. So from the little ones doing what we are going to do today in our video, up until adults with experiencing chemistry and just getting them to be hands-on with some science and so forth. So in today's session, we'll be looking at, as you said, unlocking kitchen chemistry. So this is the first one of 4 sessions that we will have with you at SciFest. And we will unlock science today with the kitchen chemistry in the sense of that people will be able to do the science experiments with us by making use of some ingredients or equipment or chemicals that's in their homes. And I just want to stress it that if there's anyone at home that does not have any of these ingredients with them, they really don't have to worry about it. The video is being recorded and so on, and they'll be able to watch it again once they have the ingredients. So today's one is just to show you that we can do chemistry and science and so on with what we do have. I know during lockdown, people wanted to do things and that not everyone knew what they could use and do. So this is just a little fun intro of what you can use with what you have at home. Yeah, so that is from me. I'm really excited to be here. I just want to say thank you to our sponsors. You will see them on the video for allowing us to be part of SciFest 2020. And yeah, thank you very much. And I hope you guys enjoy the video, and afterwards that you will flood us with all your questions.
Good afternoon and welcome to SciFest Africa 2020. My name is Leandra Taylor and I will be your creative scientist this afternoon, all the way from Split Second Science. So today we are going to have some serious science fun. And why I'm saying that is that all the experiments that we are going to do, you will be able to do at home along with me. Between the experiments, there will be time where the ingredient list will come up on your screen and you will have a few moments to collect the ingredients from wherever you store them in your home. But no worry, no fuss. If you don't have any of those ingredients at home, it's not a problem at all. You can always go and find it or buy it at another stage and just rewatch the video. But before we can start today's fun-filled event, there's two things that we need. And the first thing is safety goggles, a pair of safety goggles. And the second thing will be our lab coats. The lab coats are to protect our clothes and the safety goggles to protect our eyes. We only get 2 pairs of eyes, so we would like to keep them. If you don't have any of these at home, that's also not a problem. You are welcome to take a black bag, one of those bin bags, and just cut a hole for your head and for your arms, and that will be super duper enough to do the trick for this afternoon. So stay with us. Have a look on the screen, and in the next few moments, the ingredients will appear on your screen, and you can get yourselves ready to collect it from wherever you store it. I'll see you just now for the first experiment. Welcome to our science table this afternoon. And this afternoon we are really geared for some serious science fun. And you can have the same fun at home. It's as easy as 1, 2, 3. Woo! So, welcome to my two helpers this afternoon. This is Miane and this is Isabella. And they are going to be my mini scientists for today. But don't let age be of any concern. We can have anyone from 3 years old all the way to grown-ups doing what we are going to do today. So call your friends, your grandparents, your moms, your dads, whoever, to come and enjoy and sit in on the fun today. Right, so our first experiment that we are going to do this afternoon is called oobleck. And I just want to share a fun fact about oobleck with you. Now, oobleck was created by Dr. Seuss in one of his books, where it was called Bartolomeo's and the oobleck. Yes, it took me a while to remember the name of the book. But this is where a little green blob fell from the sky and just caused chaos and havoc in the kingdom. And we are going to make our own oobleck today to see how that oobleck looked like and what it felt like. So on your screens, you will see that there will be a recipe that will come up, and then you've got a few seconds to go and look around, shop around in your mom's kitchen for the ingredients that you will be needing. If you don't have it, don't worry. You can always watch the video again and enjoy doing the experiment with us. That all of you have gotten some of the ingredients that was placed on the screen, and we are going to work through the recipe now. So, girls, are you ready?
Yes.
Are you sure?
Yes.
Can you say it a bit louder so they can hear?
Yes.
Awesome. So for this experiment, we have a little plastic bag, and I would like you to please put your hand inside the plastic bag like this. Okay, are you getting the opening? There we go. All right, wave at everyone at home. There we go. So what we need to do is you can take out your hand now, and we can just fold it over once and twice so that it is a nice little packet like this. Okay. And then in this packet, you can put it into your plastic bowls that we have. There you are. You can just place it in there. And our first ingredient that we will need will be our cornstarch. And we have some cornstarch in this tub, and it's a big container. So what I'm going to do is we need about 60 grams of cornstarch. So Isabella, can you please hold your tub or your plastic bag for me? There you go. And then Miane, for your one. Okay. And then I want to play too. So I'm going to put some in my plastic bag as well. And today I'm going to show you how to make colored water also. So girls, can you see that we have these little plastic bottles? Okay. And we have our conical flasks with some water in it. So I would like you to please hold your little plastic bottles. Yep. And we are just going to fill them. Now these plastic bottles can take 50 mils of water, 50 milliliters of water. And if you follow the recipe at home, this is a bit much, let's just, yeah. If you follow the recipe at home, you will see that we use 50 milliliters of water for 60 grams of starch. But because we're going a bit over and beyond, we are going to have 2 of these little bottles just for in case. So this is the 1, 2, and Isabella, yours. And then also you can see that this water is clear, but we said we want to make some colored water. So girls, what would we put in this water to let it change color?
Food coloring.
Food coloring. Well done. So I have orange. Miana, what color do you have?
Purple.
Purple. And Isabella, you have?
Pink.
Awesome. So all of you can count to 3, right?
Yeah.
I can only count to 3. Everything I do, you saw 1, 2, 3. I just count to 3. So I want 3 drops of the food coloring into your bottles with the water.
Wow.
So let's go. 1, 2, 3. And 1, 2, 3. Okay, it's okay if there's a little bit more coming out. It's not a problem at all.
3.
Yep, if you squirt a little bit extra, it's fine. The only thing that's going to happen is your color will just be a little bit darker. Right, so girls, now we are just going to put our hand on our little plastic bottle like this. We're going to do this and this and this and this. There we go. And then we're going to do the same with the other one. Hand on top, and this and this and this and this. Was that fun?
Yes.
Okay, and then we can just rub it dry. Now at home, I'm sure you will have a little tub with a lid, so you can just close it all up, shake it, give it a nice shake, and your colors will be mixed. Or you can use a little spoon or a little stick just to stir it. So girls, now what we need to do is we need to take one of our bottles with the colored water and pour it into our bag. Okay, so empty all of that water into your bag. And then to start off with, almost to finish off with, let's just say half of the other bottle. Not all of it at once, just about half. Yep, that's perfect. Okay, and then I need you to unroll your bag, the pieces that we had at the top, and you need to hold your bag as if you just bought yourself a nice little goldfish. Yes, and give it a massage. So get some of that powder, get some of the liquid to run into and mix nicely with the powder. Don't squeeze too hard so that the packet breaks. Yes, just give it a nice massage. Okay, let's see how this is going. My one is a bit runny. Now, science doesn't always work out the way that we would like it to work out. So if your substance is too runny or too watery, all you need to do is you can add a little bit more of the cornstarch.
If it is too thick and sticky and hard, then you can actually add some more water. Now, oobleck is what we call a non-Newtonian fluid. And a non-Newtonian fluid is a fluid that when we add a force to it, like in this case, we are squashing it, pressing it, that is adding a force. Then it becomes rock hard, it becomes a solid. And when we leave it and we don't exert a force onto it, it becomes all runny like a liquid. So that is what a non-Newtonian fluid is like. So Miane, I think your one is almost perfect, but I think you just need to put in a little bit more water. There you go. And please give it a little bit of a squeeze. Bella, let me see. Okay, your one, I think you need quite a bit more cornstarch. Yours are too runny. Okay, so give it that massage. Let's see. And I want to see mine. Yep, mine is also too runny. We went quite bonkers with our water. Okay, so let's rub it in, rub it up, dub. Okay, is it becoming a bit more like a solid? Okay, and if you leave it, is it becoming runny?
Yeah.
Okay, so I think yours is perfect. Oh, that your bag break, not a problem at all. So Miane, your one, let's just let it, whoopsie, run to the side. There we go. And we are going to let it run out of your little bag. So if you can just hold the bag for me like that for a little bit. Let me just see how mine is doing. Now, look at this. I need a little bit more water. Okay. And let me just squash it. Let me see yours. Bella, yours is perfect. So can I ask you to hold yours up nice and high and then let it run out into your bowl? Okay, Miane, you can put your plastic bag just on the side of your tray. I think yours is perfect. Yes. Okay, there we go. And mine, just want to see if I let mine go. There we go. I'm also just going to let some of mine run out of the bag. And you can see it's a nice thickish substance that is flowing. All right, how cool is that? Okay. And let's see how much I can still get out of my bag. Bella, you can also put your one on the side. And we're just waiting for mine to run out. Okay, so you won't always be able to get all of your oobleck out of your bag. And remember, the more you try and squeeze it to get it out, the less you are going to get out because it's going to become solid in the bag. So Miane, let's see yours. Yes, and Bella, cool. So what I want you to do is, I want you to place your finger into the oobleck. Okay, and can I ask you to maybe put in all 5 your fingers and hold it there, hold it there. And then I'm going to say 1, 2, and on 3, you need to jerk out your fingers. Okay, so are you ready?
Yes.
Once again, I can only count to 3. So 1, 2, 3. You're lifting up all the whole bag. Okay, so do it again, but don't hold your bowl with the other hand. Okay, so let's put it in. Fingers in, fingers in. Are you ready? Are you ready?
Yes.
Okay, why aren't we smiling? Are you concentrating so much? Okay, here we go. And 1, 2, and 3. How cool is that? So basically what happens is, cool, Miane. Right, so basically what happens is when you put your fingers into the oobleck, right, it's just
while your fingers are there, it's becoming a liquid. But as soon as you pull your hand out, your fingers out, what happens? It becomes a solid because you are exerting a pulling force onto the liquid. And as you pull it out, because of that pulling force, it solidifies and then it wants to pull your fingers back. And hence the ball comes with when you pull out your hand. So how cool is that, girls?
Cool.
Okay, thank you very much for your help. So we are just going to let that, yes, run. So you can actually let it come out of your tub, take a handful, and let everyone at home see what it needs to look like. How cool is that? Yes, and you can take some out, make a little ball, exert a force onto it. Okay, make a little ball. Also want to see if I can get some of mine out. Okay. And do you have enough to make a little ball? Okay, there I have a little ball in my hand. And when I let it go, becomes all runny. Make a little ball from it, Miane. Isabella, make a little ball. Apply some pressure. See? And then hold it in your hands like that and let it run so they can see. Now, mine is a little bit more of a solid because I think I have still a little bit too much cornstarch in mine. But that is great. So everyone at home, we are going to give you another few seconds to get your next ingredient that will appear on the screen so that you can see how we make oobleck with a twist. And that twist is where we change this oobleck into a Play-Doh. We'll see you just now. Welcome back, and I hope you had some flour that you can use in the next part of our experiment. So just to finish off with the oobleck, we said that if you put your hand into the oobleck and you pull it out, then what happens? The tub came with. But now if you start poking, girls, poke it, right? What happens? Does your finger still go to the bottom?
No.
No, it stays on the top. Yes. And all right, thank you, guys can stop. But if a nice fun fact as well is that if you make enough oobleck, you can actually walk on it. So that is very awesome. Yes, that's so cool. So now we wanted to change this oobleck into some Play-Doh. Right. So I'm going to take my scoop. Now, usually you can have some flour and some salt and so on, and you can make some dough. But if you already have your oobleck, you can just go with using the oobleck and then a little bit of flour that you can mix in until it becomes like a dough. So I'm going to take my measuring spoon over here. And Isabella, I'm going to put some flour in for you. And then you can mix it. Here, there's some flour for you. And you can mix it with your hands. And let me know if it becomes like a dough texture. So let's mix it all in. Tell me if you need some more. Okay, it should stop being as runny. Oh, yours, perfect. Okay, there we are. And Miane, I'm going to give you a little bit more. Okay, so let's take it all, put it in a little bowl and see if it stops being runny. Okay, how are we doing over there? Still runny? Yours still runny? Mine is still runny. So I'm going to add some more in here. Isabella, how's yours?
Look at mine.
Almost. I'm going to look at yours just now. There you go. A little bit more flour. A little bit more flour. All right, so we need it to set so that it is not like the runny oobleck anymore. Still runny. Can you make a solid little ball? Mine is almost. And yours? There we go. Okay, let's keep it in our hands and let's roll it. Okay, and there I have a nice ball of dough. And it's not runny as the oobleck is. How's it going on that side? Let me feel yours. Yes, yeah, we have some Play-Doh. Awesome. And it's not runny anymore. Let me see yours. Awesome, girls. Job well done. See, and it's not runny anymore. So, girls, I'm going to let you take your dough home and you can actually go and make a little something of it. And then if you want to keep what you have made, all you need to do is put it in the sun for a few hours and it will keep its shape. We will be right back just now. Watch your screens for our very last experiment that you can do at home. So for our third experiment today, we are going to make our own paint and we will be able to use our fingers doing some finger painting. Show me your fingers. Yes, the wind is starting to blow. It's a bit cold, but we will persevere. We're going to do some finger painting. Okay, so girls, your big spoons. Miana, you're going to start with your one and I will just take the flour that we will use. I'm going to take out this measuring spoon and please scoop one big scoop. Yeah, it's fine. You can use that like that. Yep, into that space and then into the next one. So you can have some, you can use muffin pans or you can use some tubs or some pudding bowls, whatever you have that you can use. Great, that's it, that's it. Just three, we only have 3 colors today. And Isabella, your turn. You can take a scoop into each of those spaces. See, once again, 2, 3. 1, 2, and 3. Awesome. And then my turn. Let's see. 1, 2, and 3. Great stuff. So we're just going to put it over there. And then we need to mix some colored water again. Can you girls remember how we did that?
Water and food. Yes.
Water and food coloring. Right. Miana, so can you please take some of that water from the conical flask and pour it into our jug? Just like that. That's fabulous. Right. Now, can you put a little bit of the water, pour a little bit into your tub? Just like that. Or make it a little bit more because we are going to share colors today. That's it. Super. Thank you very much. And then I will put a little bit in my tub. And Isabella, there you go for a little bit in your tub. So girls, what color would you like this time?
I want pink.
You can have pink
I want purple.
and purple. And I'm stuck with orange again. So in your tubs, let's put in how many drops?
3.
Okay, let's see. 1 in your tub, in your tub, in your tub. I'm just getting bubbles. 2 and 3 and extra 1. Okay. So what you can do is you can take your big spoon.
That's my
Oh, let's not use the big spoon. Let's use our teaspoons and let's just stir our colored water. Okay. Then girls, what we need to do is we need to put in a bit of water, about half of this measuring spoon. So this measuring spoon is about 15 milliliters. So you will need about 7.5 milliliters. So let's say just 7 milliliters. So let's just pour half of it in. Half, yep, like that. Okay, and or maybe a little bit less. Put it into one of your, little bit less. It must be half a spoon, half a spoon. Okay, and stop, stop, stop. Yes. A little bit less. Let's do that. Okay, pour it in. And then we need to stir it. Everything, yes. Okay, so if you see you still have too much flour, then you can add a little bit more of the colored water. So then we can pour a little bit more into our spoon again and pour it in slowly but surely. And then we need to stir it. It's fine if you make a mess. Okay, here we go. And a little bit more. It needs to be a little bit runny. Okay, we'll show the friends at home just now how we are doing this. Okay, a little bit more, Miane. Isabella, you can put in more. See, mine is becoming a paste, but we want it a little bit more runny than that. Okay.
Like this.
And a little bit more runny, like this.
Just a bit more of this color.
Yes, please put in some more color. Okay, and Isabella, how are you doing? Yes, stir it right up, stir it right up. That is perfect. Okay, now let's see your one. Maybe just a little more. Where's your spoon? There we go. A little bit. There we go, and stir it. So there's no exact amounts when it comes to these. The exact amounts that we've given you on the recipe, that is what you can use just as a guideline. If you need to put more of the one or more of the other ingredient, you're welcome to do so. All right, now let's swap. Okay, so we're going to do this. You can swap with me, I will swap with you, and you can have that one. Now, girls, now we go to the next part.
Say
There you go. Oh, right. Sorry, Isabella. We'll just do this fun thing of being outside. You can make a mess and no one really cares. There we go. And put some food coloring in. You can use your other finger to just clean off your spoon. And we can mix up the next one so that we can have some different colors that we can paint with just now. If you need to add in a bit more, you can add in some more. Right, how's it going, girls?
wow.
Oh, wow. Feels like we are baking, not doing science. But you know what? Science is everywhere. Everyday science. Okay. And stir it up, stir it up. Are you guys stirring? Okay. And I'm just going to put in a small little bit more. I hope you guys at home is looking and watching at how much we actually put in, because I think we have totally forgotten how much we are actually. Yes, that is great. Okay, Isabella, how are you doing? That is perfect. Are you ready to swap? Okay, so I'm going to swap with you, and there we go. And now the last one. Okay, pour it. I'm just going to do that. And there we go. It's fine if it's not all smooth and so on. This is just a nice fun paint that we can have at home if we don't have time to go to the shops, or if we don't have money to go to the shops, we can just do it with flour and some colored water. Miane, do you need a little bit more water with some orange? Okay, there we go. And let me put some orange drops in for you. Oh, your hand's purple. Don't worry, your hands are going to be all three these colors just now. Isabella, how's your pink coming? Oh, perfect. Okay, and my purple is basically ready. I'm going to put in a little bit more. And there we go. Okay. I'm just going to put this out the way, this one out the way. That looks awesome, girls. So what we can do, oops, let's put this also just out the way.
Is this?
That is fine like that. So girls, what we can do is each of us can take a page, and then you can just paint a short little something. Whether it is ABC or 1, 2, 3, whatever you can. and then we can show the friends at home what it is that we have painted. So Miane,
Must we use our fingers?
you can use your fingers because we're doing some finger painting with our homemade paint. Okay, you can also just make your fingerprints, that's fine too. Okay, this is so cool. Are you guys enjoying it?
Yes.
Okay, and I'm going to do this. Okay, oopsie. Let's do that. I think I'm going to need more paper because I want to do something special. Okay, and I got one pot. I think I need some more paper. You guys having fun?
Yes. Yes.
Okay, woo! And we are, oops, we are blowing away. That's fine. And you're welcome to use a paintbrush if you have one at home. We don't have paintbrushes, so what do? We just use our fingers. There we go. Are you almost done, girls? Okay. If you are done, you can hold up your pictures for the friends at home and for our viewers to see what you have made. Okay, are you ready to hold it up? Because I'm going to need you to help me hold up what I have painted. And quickly, oh, see, I'm running out of fingers even. Okay, here we go. Are you guys done?
Yes.
Okay, show our viewers your pictures. Hold it up. 1, 2, 3. Show them what you have made. Oh, the wind is blowing. It's not working so well, but it's awesome. And guys, you that are at home, please send us some of your remarks and what you think of our finger painting skills that we have. And then I want these two girls to please help me to hold up my painting. So are you guys ready? I need an extra pair of, well, extra 2 pairs of hands. Are you ready? Okay, put your paintings down. Put your little hands on top. Okay, Bella, I want you to please hold this one like that first so that the viewers can't see. And Miane, let's see if I turn it around now, then it needs to be this way to hold this one. And you need to hold this one. And I don't show them yet. Don't show them yet. It's going to be a surprise. Okay, are you guys ready? So we're going to go 1, turn on 3. We are going to show them what I have painted. Are you ready? 1, 2, and 3. Happy SciFest 2020, everyone. Hope you had loads of fun with us this afternoon. But you have to keep at it just for a few seconds more because I have a very big surprise for you. So in the next few minutes, I'm going to show you how to make a big bang of your own. You're not allowed to do it at home without supervision. And preferably, please get a parent to rather do that. Okay, let's be responsible. So for our last experiment today, I would like to show you how to make your own hydrogen gas. Now, hydrogen is element number 1 on the periodic table. And over here, I have some helium in my helium tank. And helium is number 2 on the periodic table. So to talk you through the process of making your own hydrogen, I have to stress the fact that you have to be extremely, extremely, extremely careful. Please ask an adult to be with you and rather let an adult help you and do it. And this is something that you should rather not try at home, but we do have homemade chemicals and things that we can use for this. Okay, so the first the first chemical that we will need is our caustic soda. This is a base, and this is what we use to clean your drains and so on at home. Then I have a funnel and I have a bottle. So any glass bottle, please don't use plastic, that will melt, as this will be an exothermic reaction that will cause the bottle to melt, as exothermic reactions give off heat. Then you would need some water, and very important also is some aluminium foil. So the first thing that we are going to do is I'm going to add a few spoons of the caustic soda to my glass bottle. There we go. 1, oops, I've got some big pieces in here. 2, 3, 4, and about 5-ish should be enough. Okay, and then we will add some of the water to our bottle. There we go. And about quarter way full, halfway full should be relatively enough for that. And then after that, we need our aluminium foil. So to save some time, I already made a few pieces of aluminium foil that it's just strips that I peeled off the roll. And what we need to do with this is you need to change this into a little worm. So how do we do that? Just crumble it up like this, squash it, squish it, and there you have your worm. So this is what I'm going to do with all of these, is just to crumble them, squash them, and make sure that I use all of these pieces for my experiment. And this is not you don't have to be very arty, or you don't have to do it very pretty. It just needs to be squashed together. Oops, I'm blowing away. I'm just going to put that over there. And another one. There we go. So generally, it doesn't really matter how many pieces. There's not a set amount of how many pieces of aluminium foil I add into the bottle each time that I do this experiment. But you do need enough for this reaction to take place. Okay, and this seems to be my last piece. I'm just going to squash it like so. And over here, just to give you an idea, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of aluminium foil. And they weren't all the same size or anything like that. It's just because the metal will react with the base to release hydrogen gas. So there we go. I'm adding all of these pieces into my glass bottle. There we go. And then I will take my balloon. So for this, you need a balloon as well. And we will just put that over the top of the bottle, give it a nice swirl, and we will wait for the balloon to inflate. So you will see this balloon starting to inflate, and that will be due to the hydrogen gas that is being released by the metal and the base that is reacting. So we also want this to be party balloon size. So party balloon size is a nice size like this. We don't want it too small. We don't want it too big, because then gaboom, before we want it to go gaboom. And you can see here the reaction is already taking place. And if it's a nice warm day, it might take less time to inflate. Okay, but because it is quite chilly now, This might take a little bit longer. So while we are waiting for this balloon to inflate with the hydrogen gas, I would like to show you the difference between hydrogen gas and our helium. So between element number 1 on the periodic table and element number 2 on the periodic table. Now for this, I will need a second balloon. Let's just see how this one's doing over here. A second balloon, and I'm just putting it over the nozzle of the helium, and let's inflate our helium balloon. So in my red balloon, I have some of my helium, and helium is a gas. It is extremely light, and I am just going to tie it here with a knot. Okay, and let's quickly have a look. And I have to tie it because you will know from your party balloons what happens when you have some helium in your party balloons. Yes, it floats. Okay, so the wind is taking this one a little bit, so that's why it's like kind of floating all over the place. And then over here, we have our hydrogen balloon still busy inflating. So just to recap, what we used is for the helium, I've got my helium tank. For the hydrogen, I had the aluminium foil, I had my glass bottle, and I had a balloon, my caustic soda, a funnel, and some water. Now, this balloon is about party balloon size now, and I can hear the gas that it's busy inflating. You can also see that it is bubbling. Okay, it's busy causing a reaction. And when I touch the bottle, it is quite hot. Like I can't keep my hand there for too long as it is quite warm. And you can see now it's bubbling quite a lot as the reaction is becoming more vigorous. And we said an exothermic reaction because heat is being given off. Now I think this size is good. I'm just going to use my glove to take it off because like I said, it is quite hot. And what you see coming out of this bottle is not water vapor or steam or anything like that. No, it is hydrogen gas. And we don't want to inhale that as this it can cause you to cough and all sorts. So this is what hydrogen gas looks like. I'm just going to put it over here, out the way, and you can see that I used a very thick glove to handle that bottle because it is extremely hot now. Okay, so I'm just going to give this balloon a knot. So the pink balloon is my hydrogen gas balloon, and the red balloon is my helium balloon. Okay, so let's just tie this. And the secret here is not to let go, because if you let go, then you have a bit of a problem, because then your balloon will float away, and it won't be because of the wind only. It will just be because it is extremely light. So I'm just going to remove this from the table. Okay, and I'm going to use some press stick to just keep these balloons. Let's see. Let's tie it over there. I'm just going to use some press stick to keep it from floating away. Okay, otherwise I'm going to have a bit of a problem when I want to ignite them. So yes, it's always a good idea to have some press stick close by. Okay, and then this one, so I'm going to put it there on the side over there. And my red balloon is a bit small because that was the very last of my helium. Okay, so over here, there we go, our two balloons. And now to be safe, I'm going to put on my safety goggles. And I want you to see if you can see or pick up what the difference is between the hydrogen gas and the helium gas. And the first one that I'm going to ignite will be the helium in my red balloon. So let's just put this out the way. And this out the way. We'll just move all of it here to the side. So we've got this one also just to the side, so we can have all our focus on our helium balloon. Okay, I have my lighter here, and I'm just going to give it a bit of time. I just want to see that we make sure that the wind is not interfering. So I'm just going to wait for the wind to calm down a little bit, and then I'm going to ignite my helium balloon. Okay, are you guys ready? 1, 2, and okay, so that was just my helium balloon that I ignited. Nothing major. Let's see if we can get a different reaction from our hydrogen balloon. Okay, so we said both of these are gases. The helium is number 2 in the periodic table. Hydrogen is number 1. And let's see if we get a different reaction when we ignite our hydrogen balloon. Ready, steady, here we go. Okay, and there you have it. So let's see if you all picked up on what the difference is between the two. First one was my helium balloon, and it was not flammable at all. It just made pa, right? But the second one was my hydrogen balloon, and hydrogen is extremely flammable. So that's the difference between element number 1 and element number 2 on the periodic table. I really hope that you guys enjoyed our science fun that we had this afternoon. And just to recap, we had oobleck that we made, and oobleck is a non-Newtonian fluid, which means that when you exert a force onto it, it changes form, becomes a solid, and if you leave it, it just runs and starts to flow like a liquid. We get different non-Newtonian fluids, for example, tomato sauce, custard, honey. Those are all examples also of non-Newtonian fluids. Then we also took the oobleck to another level, and we changed it into Play-Doh that we could use. And thereafter, we made our own paint, and then we ended with a big bang. And all these experiments were done with chemicals, household chemicals that you can find in your home somewhere, whether it's the kitchen or the bathroom or wherever you store these type of chemicals and ingredients. So I really hope you enjoyed it with us, and please watch and follow us to see when we will have the next experiment session, and that will be a big live science show. Keep following us on Facebook, Instagram, and watch out for our next live science show that's coming your way.
Wow, that was amazing. I will definitely try out these with my daughter. I'm sure our viewers were captivated by the session and have some comments and questions for you, Leandra. Are you ready for that?
Yes, I am. I hope I am.
Okay. The first comment we have is from Annaline. She says, "That's so cool." Okay.
I have to say,
We
Lisa,
have a question.
during lockdown, we did some live sessions over Facebook as well. And one of the comments was, because I had some helium and I did it in my kitchen. And one of the comments was, "You're such a cool mom. You've got helium in your kitchen." So it's just because I have to cart it along for all the shows, but yeah.
Okay. A question from Siaka Kolisi. He says, your biography seems interesting. I'd like to know how your personal life interlinks with science engagement and communication.
Okay, Louisa, so basically, science, it's not just a job for me, it's really a passion. And I like to bring it into conversation and take it wherever I go. So it's always been a part of me. I've done many different things, exploring and so on. But I ended up basically doing talks and so on science, and my speeches are usually different. I bring in the experiments and not just slideshows or so. I'm also busy writing a children's story book. It's based on little Bible stories with some science experiments to demonstrate certain concepts, and just bringing things, making it alive, and showing people that science is real, it's all around us, and we can use it in everyday life. It doesn't matter what your occupation, really, you're really involved with it. And I really want to also grow the love for science in my children. So you will see that they constantly on my Instagram or wherever, they are constantly busy mixing something together, or those type of things. So I would just like to be a STEAM role model, if I can put it like that, for not just for my children, but also for other people's children. It's really a passion to transfer the knowledge that I have to other people in a way that they can actually understand, and just showing them that science can be fun. Many people think, oh, it's so difficult and it's so hard to do, but it's actually, when you grasp it and you're doing it in fun ways, it sticks. So yes, it is not just a job, it is part of my personal life, and it's also part of, I suppose, who I am and what I enjoy. And it just is a bonus if you can play for a living and do something that you really, really love. I hope that answers the question.
Yes, it does. I can relate to that, Leandra. And if I may, I really wish that COVID would just end so that we can go back to outreach and doing all of that stuff freely with young learners. But online platforms are there, so it's not much of an issue.
I know I really miss the interaction, because I really get my energy from crowds of people or interacting with people. So I have to say, sometimes it's really hard to speak to a computer or to a camera or so, and there's people on the other side, but you don't have someone that you can physically ask a question at that moment or get a response at that moment. So yes, I'm totally with you. COVID must really end now.
Okay. We have a question from Annaline. She's asking, was it difficult to choose between a traditional science job and one or science communication?
Um, actually, I think the way things have just worked out for me and the opportunities that came my way. I'm one of those people that if something comes my way, I'm one of those that I would rather say yes and try it than say no and always wonder what it would be like. And I think that's kind of how I got to where I am, by not saying no to opportunities or not being scared in taking a risk and so on. Yes, sometimes things don't work out, but sometimes they do. And we won't know until we actually give it a go. Yeah. So no, it wasn't really difficult for me, because I just keep on saying yes and then going in the direction that it's pointing in.
Wonderful. I have a question here, and it reads, some parents believe food should be just eaten and not wasted through silly experiments. Is it a problem to use expired food stuff to try out experiments just so parents can be at ease?
Okay. Yes, I totally agree with that, because there are households where food is really scarce, and people don't have enough to eat and so on. So um, the thing that we do with the kitchen chemistry is not to waste food, but to, because some people can't afford toys either, or things to entertain their children with. So a little bit of food that they can spare to use is, I think it's something nice that they can do. But on the same side, yes, we don't want to waste food. And no, it is not a problem to use expired food. So, for example, if you have cornstarch or flour or something like that that has expired, you can use that. It won't cause any damage or whatever. Just don't go and eat it. But the only thing is that, like, let's say, for example, you make the oobleck, then, and you use the expired things, oobleck by itself starts to go off after a while. So when you use the expired chemicals or substances or the expired cornstarch, then it won't last as long. So you won't be able to play with it a lot of days, like, let's say it lasts about 5 days. When you use the expired products, it might last 2 days. So that type of thing, yeah. So no, it's not a problem. It also depends on what kind of expired foods, but like the flour and the cornstarch, those things, no, it's fine, not a problem.
Okay, all right. And then another question reads, scientifically, what actually happens to cause the oobleck to be able to be turned from a liquid to a solid?
Okay, we're getting to the scientific questions now. Right.
Yes.
So oobleck it's very fun making it, and if you get the consistency right, it's awesome. So when you apply pressure to the oobleck, the liquid becomes more viscous, so it becomes a bit thicker, almost like when you have honey or syrup or so. So it becomes the viscosity becomes higher. So the oobleck basically builds up a resistance to flow. So where you did not apply a pressure to it, it was just a liquid. The water and the cornstarch was allowed to flow freely. Okay, but as soon as you apply that pressure, what happens? The cornstarch gets squashed or smashed together, and then it actually encapsulates the water molecules. So it kind of boxes them in, and then it causes that harder consistency that we get, and it changes into a temporary semi-solid material until you leave it, and then it will start to flow again.
Fun ways to learn, right? Leandra, another question, and I think it's the last one. It says, what's the worst thing that could happen during the hydrogen and helium experiment?
Okay, so with the helium, nothing, it just goes bang. With the hydrogen, kaboom, death if it goes wrong. So no, it's just we make the hydrogen in small controlled quantities. But yes, it can go wrong. Like, for example, I did it outside, so you have to take into consideration the side that the wind's blowing from and so on. Because if you do it from the wrong way, you can be in the middle of the flame, and obviously you can get burned and your hair can get screwed and all those type of things. That's why we also say it's so dangerous, and it's an exothermic reaction, so it also gives off a lot of heat. So even you can see I wore thick gloves, so you can't do that without a glove, because you will literally burn your hand, because your hand sometimes ends up being in the flame. And as you ignite the balloon, that is the outlet for the gas and for the flame. So obviously, whoever ignites it, the flame is coming your way. So it is a good thing to stand away a distance, rather use a candle or a rod or something that's longer to ignite the balloon, so that you are out of harm's way. We've been doing it for quite a while now, and trained, if I can put it like that, to do it safely. So, sorry. Yeah, so that is just, just be careful. And yeah, you can get severely burned. So yeah, that's the worst.
Oh, okay. In that case, that means that we should really be careful while trying out the experiment at home.
Yes.
Any last words, Leandra, before we close off?
Sorry, say again.
Any last words before we close off the session?
Yes, I would just say thank you very much to SciFest Africa for the opportunity, our sponsors, SAAO, SAAO and SACNAS, and my company Split Second Science. And I have to say it's really an experience to do it online, and I really, really miss being in Grahamstown. It's kind of become a tradition year after year for us to visit you guys. So I just want to let you know you are severely missed. And last year we went out into the communities and we did some science shows at some of the schools, and it was just awesome. And it's an amazing experience. And so all the schools that's tuned in and watching, I would just say we really, really looked forward to being there in person with them. And since we had so much fun last year, and hopefully next year we will be able to be back, face to face with you guys. But for now, if this is the best that we can do over the platforms that we have, then we have to make the best of it. And I really hope that the learners still get the same amazing experience from all the things that you offer. And thank you for going out of your way to really making it such a huge success and giving everyone an opportunity to be part of it. Thanks for your hard work on your side as well.
Okay, Leandra, thank you to you and to the rest of Split Second Science. You guys do an amazing job. You are no strangers to SciFest Africa, just like you mentioned. And for this, I know we will continue working together. There's a message from Split Second Science and SACNASP, SAO, SciFest Africa, to our viewers. And it goes, thank
Awesome.
you.
I see you did some finger painting.
Us. I hope that
Awesome.
we cleaned up after the experiment. Thank you so much for joining us. Please do join us. We have other sessions going on. You can check out our website, www.scifest.org.za, to see what we have lined up, as well as what we'll be doing with Split Second Science in the following month. Should you wish to watch this video again, we have a recording and it will be uploaded to our website, SciFest Africa's Facebook page and YouTube channel. Also, please do follow us on our platforms. All details will be shared shortly. Enjoy the rest of your day, people. Goodbye. Can we just send a virtual high five? Just okay then. Goodbye.
Bye, Tobisa.